The first presentation of this session will be given by María Deseada Esclapez, who is a chemist and a PhD in material science. Since 2017, she is part of the innovation department of Depuración de Aguas del Mediterráneo, DAM, as an innovation project manager. All the R&D and I projects carried out in DAM always have as a common thread the mitigation of environmental impact derived from human activities. The presentation of today is titled Drone-Based Environmental Odor Monitoring, SNIFF drones. So the floor is yours.
Thank you. So a SNIFF drone project was the result of a successful collaboration between DAM and IBEC, concretely the group led by Professor Santiago Marco. And the main purpose of this project was to achieve a drone with olfaction capabilities able to provide measurements in odor concentration units and especially focused for complex industrial environments such as wastewater treatment plants, which had several emitting foci with complex kind of gas mixtures which are emitted simultaneously. For achieving this main purpose, we had to address some challenges. The first one was the construction of a custom e-nose that integrated 21 sensors of 3 different technologies, and to include these e-nose into a drone, together with a sampling system that allowed us to calibrate and validate the whole prototype in a real wastewater treatment plant in operating conditions, in normal operating conditions. So those are the main specifications of the e-nose that we developed. We had electrochemical sensors for carbon monoxide, hydrogen sulfide, ammonia, sulfur dioxide, non-dispersive infrared sensor used for carbon dioxide, and other metal oxide sensors. I will show them later. And we also used other environmental sensors for humidity, temperature, pressure, flow rate. And here you can see the set of the 16 metal oxide sensors that we included in the sensing chamber. They are mainly focused for low concentrations of hydrogen sulfide and ammonia, together with other volatile organic compounds, and other odorless gases too were included. Here you can see the sensing chamber that was very light. It was a miniaturized chamber of less than 200 grams. Here you can see the graphical user interface of the base station, where the operator can see in real time the signals coming from the sensors together with the position of the drone, and for sure you can show the results of the odor concentration units in an interpolated map. Important, here you can activate remotely the sampler, because at the same time that we were measuring, while flying over the wastewater treatment plant, we were taking samples that allowed us to calibrate the system. Here you can see how we couple the nose with the drone. We use a small drone, DJI Matrix 600, as a proof of concept, and we use a very long tubing for avoiding this downwash effect of propellers. We used, as for the sampling campaigns, a medium-sized wastewater treatment plant in the region of Murcia, Spain, with the collaboration of the regional authority, and we took samples in different campaigns at different months and over the main emitting sources of the wastewater treatment plant and at different heights. So we wanted to have a wide variety of samples with different kinds of gas mixtures for having a proper calibration. For that, we used an olfaction sampler. When we had a sample, a 10-liter sample in an cellophane bag, we landed the drone. We sent those samples to a certified laboratory, and now I will explain how we calibrated the model. We used 2 kinds of calibration. The first one, this is a typical calibration, I will explain now how it was a typical calibration session. So we took our e-nose to the laboratory, and together with the samples that we had. And for sure, it was all those samples were measured by dynamic olfactometry by a panel according to the standard, and the remaining samples were diluted. And all those samples were exposed to our e-nose, so we could construct a calibration model with 21 signals for each of the bags. Finally, as we had dilutions, we had around 60 samples. The first and the second campaign were used for the construction of the calibration model, and the third campaign for the validation of this model. Well, we had a wide variety of other concentration ranging from 40 other units per cubic meter to 96,000 other units. Here you can see how it was. First of all, we use partial least square regression method, and here in this reference you can have more details of the calibration method that we used. It will be published, I think, in 10 days, more or less. And here what you can see is the comparison between the signals achieved by the metal oxide sensors when we took the e-nose to the laboratory compared with those results achieved by dynamic olfactometry. You can see that there's a good agreement and a good baseline recovery, except in the case of the most concentrated sample, when some of the sensors reach the saturation level. Here, in contrast, what we can see is the pattern of the sensors while the drone was flying over the wastewater treatment plant. You can see that it's very different to the previous one. The pink lines show the moments where we were taking samples. Those are the results for the dynamic olfactometry corresponding to those measurements. We used variable importance in projection for assessing which were the more relevant sensors contributing to the model performance. So, thanks to this study, we could not only improve the accuracy of the model, but also to improve the performance of the whole prototype, because we could withdraw 12 of the sensors. So we had a lighter device, and furthermore, less power consumption. So it helped us to have longer periods of measurement. As yesterday explained so well, Carmen, we use this Blanc-Allman methodology for comparing the results that we achieved with those achieved by dynamic olfactometry. That is a methodology that already has an error. We can see that we had a nice correlation for all the range of concentrations, especially if we compare the results with those achieved if we only use the hydrogen sulfide concentration measurements that only works properly at high concentrations of other units. For sure, this is in logarithmic units. And finally, this is the model that we achieved if we use the signals that we achieve when the drone is flying over the wastewater treatment plant. This is a very different situation to the case that we take the nose to the laboratory. But the model is not so accurate, but on the other hand, we have a very nice cost reduction in the calibration of the model, and we have still a good temporal and spatial resolution thanks to the use of the drone. And finally, here what you can see in the blue line is the measurements of other concentration achieved while the drone was flying over the wastewater treatment plant compared with the results achieved by the dynamic olfactometry. And we can see that we have a correlation of 72% of the measurements that we perform. And for sure, we can show the results in an interpolated map, an interpolated concentration map. And finally, as main conclusion, we can say that drone mapping in real time for odor concentration with a slightly worse accuracy than the reference method, dynamic olfactometry. We think this is feasible, and those are some of the papers we published with the results. Some of them are still pending, and we presented a patent with the results. That's all. Thank you.
Thank you, Maria, for your very interesting presentation. Is there any question? If not, I have a couple of questions for you. I would like to understand if, besides the implementation of a specific sampling system to reduce the noise due to the fact that the drones is flying over the surface, if you have added to the data processing pathway specific correlation, specific pre-treatment step which allow to remove the noise or the disturbances on the signals.
Yes, this variable importance in prediction method allowed us to remove those sensors that had more noise and which gave a worse model. So this was a way of reducing this noise. Yeah.
Okay. And the second one is, have you already thought about the future perspective of these results that you achieved that are very, very interesting, because you gain a mapping of the odor concentration over the plant. Have you already imagined how to use this data as input for calculating the odor impact of the plant on surroundings?
Those kind of maps mainly help us to have a very fast overview of the procedure of the behavior of the plant, and also to check if for instance, if the processes that we have there installed for palliating those other measurements are working properly in a very fast way. And I think that this can be a powerful tool that can be, we think that it has potential to be improved. For instance, I think that we will have now another speech about how to measure these emission rates. And I think that this technology has a long way. And I think that this is the first step, and for us, we are happy with these preliminary results.
Okay, thank you very much.